Hi guys, good morning. Welcome back to a new video. Ki halchal? I hope you're doing good. In this, we're going to see separate squares one. Again, the like target for this video is 75 likes. It will be pretty great if we can do that. Now, it simply says that you're given 2D integer array squares, and basically a square they are representing by its xi, which is xi comma yi, which is the bottom leftmost point of that square, and also given the length of the square. Again, if you don't know, the square has all sides as equal, so both the length and the breadth, or you can say the height and the breadth, will be same. Now you have to find the minimum y coordinate value of a horizontal line such that the total area of the square above the line equal to the total area of the square below the line, which means that I have multiple squares on my plane. Multiple squares. It can be overlapping as well, but we have multiple squares. Now I have to draw a line such that that specific line should have equal area both down and below, which means below this line as well, above this line as well. Now, whenever there are overlapping squares, obviously there will be multiple questions which can come up. The first question is, area is considered multiple times or same time, which means if I have a square which is overlapping, should I consider this area plus this area, or should I consider this area plus the remaining area? In this, they are saying that you can consider overlapping area multiple times, which means that I can consider area as this entire area and this entire area. So I can easily compute the total area by taking a summation of all individual areas. And why this is helpful? This is helpful because you don't have to go ahead with overlapping problem, but its follow up, which is pretty hard, which is follow, will actually say that you are now, like, you will now have to consider that overlapping portion, which means that you can only consider this area and the other area. You cannot consider this common area twice, which ultimately brings us to a fact that the next problem will be based on more of overlapping sub problem, which will obviously kind of involve line sweep, and just as a spoiler, it will involve segmentary and coordinate compression as well, which is again pretty complex in terms of the follow-up. But still, again, we might not discuss that because it's pretty tough, and probably most of we will discuss as a daily problem. But yeah, this one, let's continue this one. So this one says that okay, now I can consider the area. Is there anything else which you are missing? Yes, this one thing, that answer should be within this of the actual answer expected, which means that it is not necessary the answer will be a whole integer. It can be in decimals, like, it can be float, a double value. And that is how we can easily see with the help of this example that they should be precise enough in a precision value of 10 to the power minus 5. Now, lastly, one very standard fact that any line can divide it. This line can also divide, both areas are equal, and also this line can divide it. The only catch here is we have to find the minimum line which divides it. So that is the reason we have to take the minimum y coordinate. So what I will do, okay, I will try for all the possibilities. What are all the possibilities? All the possibilities is that I know my squares will start off from the 0, y-axis as 0. How I know that? Because I know my xi and yi starts from 0 and go up till 1e9. So if I firstly ask you about the range, that how long this can go, obviously my last square, his x and y can be 1e9 comma 1e9. This square length itself, if you see, it is again square length itself is also 1e9. It is also 1e9. Thus, if this is 1e9, the topmost point, this one, it can be 1e9, or I should say 2e9, and then again 2e9. So this is the topmost point, or maximum point of the entire square which I can have at 2e9 comma 2e9. Okay, let's start finding the answer. The answer says trying for possible y value which will divide my square in the equal half. So I will try the very first one, minimum one. Then I can try the next one. But again, make sure that you have to try in a precision of 10 to the power minus 5. So technically, when you are trying this thing, next number which you should try will be 0.000012345. You have to try 0.0012345. It is 1 into 1 2 1 2 3 4 5 6. Okay, 1. So you have to technically try this number next. Then again the next number will be 0.00002. Then next again, this is how you will keep on trying, and at a point, let's say at y is equals to 1.00000, you got, okay, when I say try, which means try for all possible y value, and when you try that, at one point you will find out that lower area and higher area both are equal. In this scenario, when both lower area and higher area are equal, I will be good to say that I have got my answer. Now, is it good? Obviously not, because if I talk about the time complexity, it will be pretty high, like literally pretty high. Why I say that? Because obviously you are going on into this precision. So you have at max 2e9, which is 2 into 10 to the power 9, and at each one distance I have 10 per 5 more precision values which I have to try. So technically I will be trying for 2 into 10 per 9 into 10 per 5. This is what you will try, which is this is all possible values which you will try for y. Are you going to try that? And this is only I am trying the values. When I will say for a specific y, I will have to compute the lower area and the higher area as well. Lower area and the above area as well. Only if they are equal, okay, I will be good to go. Elsewise, I will keep on going up. And this will bring me my complexity as this thing, which is all possible values of y. And for one possible values of y, let's say take this value of y, let's say erase this, let's take this possible value of y. I will be trying taking the summation of everything above this and everything below this. Again, I will tell you how I can find that, but I will find everything above this as area, everything below this as area. Technically means that I will go on to all the square and will ask, bro, is your bottom line above myself? Yes, okay, it is counted in the above area. If not, it is counted in the below area. And that's how my complexity will be this thing into going on to all possible squares, which is in worst case 5 into 1e4. So 5 into 1e4. This itself was giving TLE. Now, along with this, obviously it will give you TLE. How to do that? Obviously, you saw that I was doing a simple linear search, which means that if I erase, I was going on to all of these possible values in a linear fashion. Go here, go here, go here, go here, go here, go here. Oh, at this point, it got satisfied. At this point, it got satisfied. Now, when I say I was doing a linear search, technically what I was trying to achieve here, I was simply trying to achieve that, okay, you will find as you are going, at this point in time, you will find simply an area where your lower will be equal to your higher, which means that every point in time as we are going upwards, I can compute my lower area, I can compute my higher area, I can have a simple check. Again, I want to do a binary search technically, but for the binary search, that the condition should be right, 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 and then some point wrong, no, no, no. This is how a binary search should look like. I know I was doing a linear search. I know I want to transform the problem to a binary search, but for a binary search, this should be a fashion. Now, how I can transform my problem statement into this fashion, because it is now talking about area. I never know what is the area above and below, because if I go at a random point, I never know that, okay, what is the area below, what is the area above. Even if I find that area, then how I will make sure that I'm moving my this line midway into a correct place, which is moving it below or above. How will I know that? So I have to figure out a statement which will be true and then false. Again, it can be anything. How it can be anything? One possibility is that you find the lower area and just equate that to a half, which means that the total area of all these squares. Again, I'm just telling you one possible way. There are multiple possible ways. I can find the total area of all these squares. Total area divided by 2 will be the area of the below half of my square. Now, if I have some random midway, I will check the below area. If the below area is more than this, obviously this line should come down. If the below area is lesser than this, obviously this should go up. This is one way how we can actually go about in moving my mid-y. Again, if you don't know mid-y, what I'm talking about in binary search, please go and check out crash course section. Just go to crash course section and then just search and learn about the binary search basics. Just one video is more than sufficient for you to actually learn it. Cool. And again, with that, I'm expecting that you know how to write a basic piece of binary search code. Cool. Now, coming on back, again, if you want to practice for binary search, you can just check out the questions, in the practice problem sheet. Come to binary search and practice the questions of binary search. It will cover all the problems with videos in structured manner. Coming on back, now imagining you know binary search, you can make a corresponding function. But again, one possible way is that, again, as I told, that lower half has larger area. So I can take this function. Again, lower half, again, this is the same thing, that lower half has larger area. If it has a larger area, if yes, then make sure that obviously lower half has a larger area, then make sure to move your y below, which means that it will come below. If your lower half is not having a larger area, okay, make your y up. So this is how I can use that same thing which I told you. Now let's summarize of how we will write its corresponding code and how we will implement it. Firstly, we realize that we have to do a binary search, but binary search on what range? The first range will be the minimum and the maximum. Now naively I told you that maximum bound, if I come back, yeah, maximum bound will be 0, 0 to 2e9, 2e9, but I'm doing a binary search on y itself. So for me, the minimum is 0, maximum is 2 into 10 to the power 9. Although you can easily, again, no doubt, you can take low as 0, high as 2 into 1e9, right? 2 into 1e9. You can simply take that. That's completely perfect. But obviously, there's always a chance of pruning, which means that rather than taking 2 into 1e9, I can rather take this as my maximum limit, which is nothing but for any square, the topmost point, topmost y point, which ultimately say that if I have, x comma y, so if I just take the example, in this input example, we are given like this, x, y for any squares. If this I represent as a square, so y will be square of 1 and length will be square of 2. And again, x I'm not concerned about, yeah, right? I'm not concerned about x because x will not help me anything with anything. So I can go through all these squares and find the x, which is my minimum x. My minimum x will be minimum of all such square of what? Sorry, it should be minimum y. Minimum y should be minimum of all such square of 1. This will be my minimum y. What will be my maximum y? My maximum y will be maximum of what? My square of 1. But I told you, square of 1 is the bottom leftmost point. This is what this is given. This is given the bottom leftmost point. I want to find the topmost point, maximum y. So that I will take as square of 2. So square of 1 is the length, so is the bottom leftmost point, and square of 2 is the actual length. So this will give me the topmost y point which can actually have, and this is how I can find the min y and max y. When I have found the min y and max y, now I can start applying my binary search. Now, as I have mentioned already, that in general we should follow a temporal binary search which looks like this. If I just erase that and showcase, okay, this is how it should actually look like. Now if this is the fact how it should look like, I should always make sure that in this case, if I apply the same thing while I is less than equals to r, if I just go back and I'll show you, if I apply the same thing, even if I is less than r or I is less than equal to r, even if I apply that thing and I say, okay, L equal to mid plus 1. Now it is jumping my L to the next possible integer value, but I have to make sure I am trying for all possibilities. That is the reason I will go by precision, and this is called as binary search on, binary search by precision. How I will do that? I will say max y minus min y. If their difference is more than the precision, then please keep on doing the binary search. When I do a binary search, I always find a mid y, which is nothing but the max y plus min y by 2. This is how a binary search looks like. Now I will go and check, a simple function which I also told previously, that lower half larger area. You know, I'll just simply have a check that is lower half larger, is a function which will say that I have a given square, I have all the given squares which I have, for all the squares which I have, make sure and check that how is mid y performing. Is mid y is lower half having the larger area? So this function will return true if the lower half is having a larger area. Now, as I mentioned, if the lower half, let's see if I just show you again, if the lower half, if the lower half has a larger area, always I should move down, which means my mid y should, my max y should come down. It should come mid y. So earlier the maximum limit was this, it will now come down to this. So this will become my max y. And this is my new area now, because I want to move the next mid below. So I want it to move down. My center of mass, you can imagine, is downwards. Elsewise is the opposite thing. Elsewise, my min y will become mid y. So this is min y will become mid y. Now come the main part, is lower half larger? So for this specific function, which is lower half larger, I will simply have to compute the lower area and the upper area. If the lower area is more than or equal to the upper area, then this condition evaluates to true, which means ultimately I will iterate on all possible squares and will find out the lower area and upper area. How to find out the lower area or the upper area? Which means if I am on a specific individual square, my mid y is this. If its top y, if its top y, if it is less than, if its top y, if it is less than equals to my mid y, this entire area will be covered in the lower area. So I will count that in my lower area. Now, if my bottom y, if it is more than or equal to my mid y, then it will be covered in upper area. But what if that I have my mid y for any square which is in between, which means neither its top y is below nor its bottom y is above. In that case, it is maybe in between. In that case, I have to say that this lower portion will be counted in the lower area, upper portion in the upper area. Which means, what is this lower portion? Lower portion is this lower height. This lower height is mid y minus bottom y into this specific breadth. Same way, upper a contribution will be upper height, which is your top y minus mid y is your height, and the length will be given square length itself. And that's how I can take the contribution of this specific square into lower area and upper area respectively. And again, after I have gone to all the squares, computed their areas and the contribution of them in the lower area or the upper area, I will simply have a check that if the lower area, if it is more than equals to my upper area, then this condition evaluates to true, which means the lower half has a larger area. Cool. Let's see the code. The code will be exactly same as what we discussed. Firstly, I will compute my min y and max y. Again, you don't have to compute that. You can put up easily 0 and 2 into 1 is 9. Right? That will also completely work. But obviously, we have to prune it, which means we have to get it done. And obviously, I took a precision. And thus, I will take a simple while loop. While will say, okay, while my max y minus min y is more than precision. Again, this is a bit different than what we see here, because here, again, this is a template I specifically recommend for simple integers. But when you're dealing with some precision, then this is perfect thing. Now, for that, I will compute my mid y, and then I will call this is lower half larger function. If it is larger, then I should obviously move my entire window down, which means my center of mass should go down. If not, the center of mass should go up. Ultimately, you have your minimum y, that is your answer. Now, if I talk about the get min y, which is this specific thing, get min y, is simply iterating on all these squares and getting the minimum y. And for the max y, it is iterating on all these squares and getting the maximum y. How? What is maximum y? Maximum y is left, lower y coordinate plus the height of the square, giving me the top y of that specific square. Now comes the main part, which is lower half larger? For is lower half larger, I will simply iterate on all possible squares and will find their lower area and the upper area. The lower area, for any square to find the lower area or upper area, I will find that specific square bottom y, and that specific square bottom top y, top y. I will square that specific y, bottom y and top y. As I said, bottom y is already given to us, which is square of 1. Top y I can compute by saying bottom y plus the corresponding side. This side length will give me the top y. Now I mentioned, what if this top y is less than equal to my mid y, which means my mid y is here, which means this entire square will come in the below. So I can count that in the lower area. If this entire thing, which means the bottom y, is more than equal to my mid y, in that case, just count this entire square area into your upper area. If it is in between, then I will compute this height, which is my below height, which is mid y minus mid y. If this is mid y minus bottom y is the height, and the side will be its breadth. And same way, above height will be top y minus mid y, and the side length, this specific thing, will be its breadth. So I'll compute and add in the corresponding lower in the above area. Now, ultimately, if the lower area is more than above area, simply I have got the answer and I can return that specific answer. Now, lastly, what is the time? As I already told you, the time in this case, as previously, if you remember, you were doing a linear search on this portion. Now you will do a binary search. So this entire portion can come in log of 2 into 1e14. But still, if you have to prove it mathematically, you can come down and you will see that I have a L. I will go to L, L by 4, L by 2. I am dividing it by 2 every step. That's how a binary search works. So ultimately, at some ith stage, I will have L upon 2 raised power I. And I'm assuming that at this point in time, I have divided such that its precision is actually, it has gone below its precision level, which means I'm safe now, which means that ultimately I can bring it down, bring it up, then I can bring this thing up, so it will become L into 10e5, like 1e5. L, I told already that the biggest possible thing, my search space is from lowest 0 to the highest 2 into 1e9. I already showed you above. With that, I will simply realize that this is my corresponding search space, and again I can just do a log both sides, and this will be my corresponding I value, which indicates that as this is like with 47 as a I value, or when 47 iterations roughly, or you can roughly say 50 iterations, you will be able to achieve a precision value less than minus 1e5. And thus my time will be n, going on to all these squares and doing a binary search on the entire length which I have, and ultimately getting a space of O of 1 because we are not using any extra space. I hope you guys liked it. Please make sure that we complete the like target of 75 likes in this video. Bye bye, take care, and please do make sure that you watch the corresponding crash course. And if you're weak in binary search, which many people are, please make sure to come to practice problem sheet, which is nothing but inside the DSA sheet. You can come to practice problem sheet and then make sure to practice it. Bye bye.